Hi, this is ET370, Lecture 11, Part C. This is the third part where we're going to talk about how binary and hex play nicely together. So we're going to convert from binary to hex and hex back to binary, right? And we'll also introduce this concept called binary coded decimal, right? Because it's kind of related here. But let's look at how do we convert from binary to hex. And we're going to start with the least significant bit, which is the rightmost, and convert every 4 bits to a hex digit. That's super nice. And recall 4 bits can represent 2 to the 4 or 16 numbers, and this is super convenient. It's actually going to make these conversions really nice. So you look at this and you're like, okay, I want to convert this to hex. Well, all you got to do is just chunk it up into 4 bits. So 1010 and 0010, right? So group it by 4 bits. So how do I convert this to hex? Well, we know that this is the number 10, right? This is the ones place, the twos place, the fours place, the eights place. So I'm taking 8 plus 2, which is 10. And what's 10? That's A. And I have the ones place, the twos place. Well, that's 2. So this is 2A. That's it. That's pretty nice. Pretty nice. None of this divide by silliness or whatever, or multiply by 16 and all that stuff. So I'm hoping you can see that binary and hex play very nicely together. Okay, let's do another example. So let's say we have this crazy binary number and we want to convert to hex. I'll just chunk it up again. 4 bits, 4 bits, 4 bits. What's 4 bits called again? A nibble, right? So let's break it up into nibbles. And so for every nibble, let's find the equivalent hex number. So 1, 1, ones place, twos place, add them up. That's 3. Okay, ones place, twos place, fours place, eights place. That's 11, right? Okay, and then what's this? Ones place, twos place, fours place. This is 4, right? Okay, so I have 3, 11, and 4. Okay, so what's 3 in hex? It's just 3. What's 11 in hex? Well, 10 is A, 11 is B, and what's 4 in hex? It's just 4. So this is 4B3 base 16. Oh, done. So simple to convert between hex and binary, right? Okay. Let's do another one just for fun. I have 1, 1, 1, 1, 1, 1, 1, 0, 0, 1, 1, 1. Okay, so what's this one? Ones place, twos place, fours place. So that looks like a 7, right? Okay, what's this one? 1, 1, 1, 0. So this is going to be ones place gone, 2, 4, 8. So 2 plus 4, what is that? 6. 6 plus 8, that's 14. Good. And this last one is going to be one more than that. It's 15. So 7, 14, 15. 7 is 7 in hex. What's 14 in hex? That should be A, B, C, D, E, F. So E, and that's F, right? Good. And so FE7 base 16 is the same as this binary number. Really couldn't get much more easier than that, right? Okay. Okay. What about going backwards? Well, if you see the hex number, just take it and convert each one to its equivalent 4 bits, right? So if I see 5, that's going to be 0101. So this is the ones place and the fours place. So that's 5. And C is the same as 12 in base 10, right? A, B, C, 10, 11, 12. And so if we want to convert 12, we can say 8 plus 4. So look at this, ones place, twos place, fours place, 8 place, 8 plus 4. And so C5 is going to be 1100, 0101. Perfect. Pretty straightforward, right? Okay, let's do a last one. D6 space 16 to binary. All right, 6, that's going to be, well, we have ones place, twos place, fours place. So I believe it's 011. Good. And D is A, B, C, D, E. A, B, C, D, 10, 11, 12, 13. So that's going to be 13. Good. So what's 13? That's going to be 12 plus 1. So it's probably going to be something like 1101 because this is 12 here. Good. So now we have D16. So just 1101, 0110. Not too bad. Okay. All right. So that's just hopefully highlighting how easy it is to convert between hex to binary, binary to hex, and how nicely these two bases play together. Okay, let's look at this last thing called binary coded decimal format, or BCD for short. And it might be an easier way to convert between decimal to binary, but it's at the cost of more memory. And it's going to be very similar to how we did this, like hex to binary. Now, what this is, each decimal number is now going to be represented by 4 bits, which we know is a nibble, same as this, right? And it's going to also handle decimal fractions as long as you know where the radix point or the decimal point is. And so, for example, 93.2 base 10 converted to this binary coded decimal, you're going to kind of play the same game as you did here. So the 0.2 is just going to be, well, 0010, because that's the binary equivalent. 3 is going to be 0011, good. And 9 is going to be 100. 1's place, 8's place, 8 plus 1 is 9. Okay, and so the entire list here, or the entire list of all this, is going to be 1001, 0011, and radix point 0010. And this is going to be the binary coded decimal for 93.2 base 10. Is this using the proper binary? No. And look how inefficient you are. You're using so many bits just to represent 93.2. Okay, so it's an inefficient way, but it is easy to go 1 digit at a time to 4 bits, right? Okay, let's do another example just so you see exactly what's going on. 197 to binary coded decimal. So you convert the 1, the 9, the 7. 1, that's easy, 0001, boom. We just did this, 1001, and 7 is 1110. So what do we got? 1's place, 2's place, 4's place. So 3 plus 4, that's 7. Yep, combine it together and you get this. Easy, right? Okay, and then the last one, let's do another one, 53.88. We know is 1,000. 3 is 0011, good. And this is going to be 1 plus 4, yep, 0101, good. Add it all together, or list them all together. Yep, you can see this is what 53.8 is, represented binary code decimal, but very inefficient in terms of memory because you're using way more bits than you would need to. Okay, what's the application for binary coded decimal? 7-segment displays. You've probably seen this on like, VCRs, that's going to date me. DVD players, oh no, again, dating me. All right, I think you guys know what a 7-segment display is, right? Calculators, yeah, there we go, calculators. I'm sure you guys have seen calculators, right? Like, yes, for sure. Time displays, like digital time displays, yeah. So these behind the scenes are using a lot of times binary coded decimal to represent these numbers on here, okay? All right, well, I hope this last part of lecture 11 helped you, and we'll see you in the next one. Have a great day.